use our rules for logarithms to help us solve these exponential equations that we have been struggling and haven't really been able to solve until now. Now we have this wonderful power rule that we've learned with logarithms that allows us to take something in the exponent and put it down in a form that we can actually work with. So we see that we can use the power rule, which is taking this power of p and rewriting that as p times log base a of m. So let's see how this works with an exponential equation. In the past, we have not been able to solve these, especially if it had this variable in the exponent. We haven't really had any tools that would help us solve these types of equations. But now we can use logarithmic properties to help us solve these. So the first thing we're going to do is make use of those logarithms. So we're going to take the log of both sides. So we're going to write log in front of both. Then we're going to use those properties of logarithms and take this exponent and put it in the front. And we have to remember that this log of 2 is really just a number. If you put that in the calculator, you would get a number out. So if this is a number times a variable and I want to get the variable by itself, I would divide by that number on both sides. And I would put this in the calculator, log of 6 divided by log of 2, and get my answer and just round to the appropriate decimals that you may be given in your problem. Let's see what this looks like for an e, a base of an e. We need to remember that e's and natural logs are inverses of each other. If you take the natural log of e, you get 1. If you take the natural log of e to the x, you get x. And so let's see how this plays out with an exponential equation with the base of an e. So the first thing we're going to do is, instead of taking the log like we did up here, because the base is an e, we want to take the natural log of both sides. We're then going to use the logarithmic properties, which still apply to natural logs, and take the exponent to the front. Then we're going to use this idea that the natural log of e equals 1 and understand that this expression is really just 1 times x, which just gives us x. So the only thing we need to put in the calculator now is the natural log of 6, and we would round that again to the appropriate number of decimals based on your problem. So now that I've gone through a few examples, let's actually work a few of these. So this first one, this is 3 to the x equals 20. So the first thing we're going to do is take the log of both sides. The next thing we're going to do is use the properties of logarithms and the power rule to move that x to the front. So this would be x log 3 equals log of 20. Then we remember that log of 3 is really just a number, and we have a number times x. So if we're trying to solve for x, we're going to divide by that number on both sides. This will cancel, and then I would put this in the calculator. Log of 20 divided by log of 3. And let's see what we get. So we're going to do it in fraction form. I'm going to do log of 20 divided by log of 3. And let's see what we get. Let's go ahead and see. This says round. It doesn't give us rounding. Let's round to 3 decimals. Okay, you just pay attention to the fine print in your problem and see if it's 3 or 4 decimals or 2 or whatever it says. Okay, so this is 2.72, and then I've got a 6 and an 8. The 8 is going to round the 6 up to a 7. All right, let's move to the next one. This is 5.5 to the x equals 30. So same process. Log of both sides first. Power rule next. X in the front, log of 5.5 equals log of 30. Divide by the logarithm because that's just a number. And put this logarithm in the calculator. So let's see what we get here. I could probably do second entry. And let's just go up and change this to 30 over 5.5. So again, if I do 3 decimals, I have 1.995. All right, now let's think about this one. We have a base of an e, so instead of taking the log of both sides, I want to do the natural log of both sides. Natural log e to the x equals natural log of 6. Okay, so we're going to take the x to the front, and then this will be natural log of e equals natural log of 6. There's no need for me to divide by natural log of e because what I would really be dividing by is just 1. So this goes to 1, and I just have x equals natural log of 6. And if I put that in the calculator, I get x equals 1.792 because that 7 is going to round that up. 1.792. So just remember, if there's an e, you're taking the natural log, and if I have natural log of e, that just goes to 1. Now let's look at a couple that are just a little more complicated than this. Requires a few more steps. So before I can do anything with an exponential equation, I need to isolate that exponential part. So this e to the 5x needs to be by itself on this side. So what is happening here? I've got 2 times e to the 5x. In order to get rid of that 2, I need to divide both sides by 2. So I have e to the 5x equals 20. Now this is a base of e, so I'm going to take the natural log of both sides. The 5x is going to come to the front. And then we need to remember, if I write natural log e here, that's just going to go to 1. So this natural log of e goes to 1, so I don't have to write it. And this is natural log of 20. And then divide by 5. So you've got a couple more steps on this one in order to get the answer. Okay, and on this one I get 5.99. All right, so again, I'm getting the exponential part by itself first. So divide out whatever you need to divide. Take the natural log of both sides. Take the exponent to the front. Remember that natural log and e go to 1. Then solve for x. Okay? All right, let's look at this one. 8e to the negative 0.5x equals 0.26. Minus 1 equals 0.26. All right, so same concept. If I'm trying to get the exponential expression by itself, I want to do the add subtract first and then the divide. So here, if I've got this minus 1, I just want to add that to the other side. So I get 8e to the negative 0.5x equals 1.26. And then now I'm left with something just like I had before. So I'm going to divide by 8. E to the negative 0.5x equals, and there's really no need to work this part out. You can do that later when you put it in the calculator. And then natural log of both sides. So I've got natural log of 1.26 divided by 8, and you can put it in the calculator just like that. And then remember that this exponent comes to the front. And this, again, natural log e went to 1, so it's really just gone away. All right, and then our last step would be to divide by negative 0.5. Okay, so let's put this in the calculator and see what we get. So we're doing natural log of 1.26 divided by negative 0.5. Oop, nope, I did that wrong. My bad. Natural log of 1.26 divided by 8. And then I'm going to divide that by negative 0.5. So I get 3.69, and this 6 is going to round that 6 up to 7. So that is solving exponential equations using logarithms.